So today we will study about the fundamental forces of nature. We experience different type of forces every day, which can be muscular force, it can be electrostatic force, it can be gravitational force, it can be any kind of forces. But on the fundamental basis, there are only four forces that has been given to us by nature, and all other forces can be derived from that. And the basic of all the forces are these fundamental forces. So let's start. We will talk about this introductory in this introductory class about the fundamental forces. So let's start the topic. Fundamental forces of nature. So, of all the four fundamental forces, the first force is very easy to understand and everybody must be understanding this, and this is none other than the gravitational force. We know it that the gravitational force is basically an attractive force which acts between two objects having some mass and which are distanced by, let's take r. They are separated by a distance r. The first object is m1, the second object has mass m2, and the force between these two is given by the very famous formula that we study in physics, and this is the force is equal to g. This is gravitational constant. We will talk about this later in more detail, but first the formula here is force is equal to g m1 into m2 divided by r square. So the force between these two objects is inversely proportional to the square of distance between these two objects, and it is directly proportional to the mass of 1 and mass of 2, and this force is inversely proportional to the square of distance between these two objects. So the first thing to understand that in gravitational force, it is always attractive. It is always attractive force, and it acts up to a distance of infinity. See the r here, it can extend up to infinity. So at infinity the force will become 0, but we will talk about this later. But it is infinite, it acts up to a distance of infinity. So this is the fundamental force, and it is pretty easy to understand. If we throw a ball up above the sky, it falls down to earth, because we believe that the earth acts on that ball and pull towards it. So gravitational force acts here. We will talk about this gravitational force later. Let's proceed to the topic. The second force is electromagnetic force. Electromagnetic force, or in short we call it EM force. EM force, and this force acts between the charged objects. See, this is a positive charge and this is a negative charge. So when there is charges, there will always be an attract and force which is called electrostatic force when the difference of this charge So it must be understood that electrostatic force only acts where there is charge. It can be any kind of charge. Let's take an example here. This is positive and this is negative. So these two charges are opposite to each other. We call them unlike charges. So when there are two opposite charges, there will always be attraction between these two. And when the charges are same, let's say the negative, let's put the arrow inside so that we can better represent it by attraction. Here the two charges are same, so the force between these two will be repulsive. And let's take another example in which we take positive charges. Since these two charges are same, so the force will be repulsive in nature. So it must be understood that the gravitational force that we just come to know is by virtue of its mass. Where there is mass, there will be gravitational force, and where there are some charges, it will be electromagnetic force. But if the object has, let's take this point, it has mass and charge, there will be electromagnetic force and gravitational force both together. But a very important point to understand is that gravitational force is much weaker compared to electromagnetic force. And we can understand this from this example, that the force between these two protons, say if it is proton and here is another proton, so they have certain mass. We know this constant mass they are having. So by virtue of mass, there will be gravitational force, and by virtue of that charge, there will be electromagnetic force. So when the force between these two protons, because of its electromagnetic force divided by gravitational force between these two charges, it is 10 to the power 36 times. So electromagnetic force is much stronger than gravitational force. So when the two objects having mass and charge, we will mainly consider the electromagnetic force because the charge here is more prominent than the gravitational force. We will learn about this later, about the Coulomb force, which is given by 1 by 4 pi epsilon naught q1 q2 by r square. See, this is constant, just like we see in here in gravitational force. This is also a constant, and instead of mass here we are having charges, and these two charges are separated by distance r, so the force is inversely proportional to the square of distance. So from this we can conclude the force, electromagnetic force, is directly proportional to the value of charges and inversely proportional to the square of distance between these two. So the formula of gravitational force and electromagnetic force is pretty much same. We will discuss more about electromagnetic force when we will study electrostatic force. So let's move ahead to the third, more fundamental, which is called a strong nuclear force. The two forces that we studied above, the gravitational force and electromagnetic force, we experience in our daily life. But other two forces, the third and fourth forces, are. So the third fundamental force is the strong nuclear force. So what is this? We must be thinking that the center of the center of an atom is called nucleus, and it is having positive charges, and it constitutes proton and neutron. You see a bunch of proton, neutron, and it forms nucleus. But inside we see the neutron is neutral charge, having no charges, but the proton is having positive charge. So how is it possible that the two positive charge remains together, live together in stable state? Because from electromagnetic force we understand that the two same charge are repulsive in nature. So how it is possible that the two protons in a nucleus remains together? This is because of another fundamental force, which is called a strong nuclear force. So the most important thing about this nuclear force, that it acts only for a very small distance, and the distance is around 10 to the power minus 15 meter. In this range, these two forces act, and when the two charged objects, say in nucleus the proton and proton, these two protons comes closer, the distance between these two protons becomes 10 to the power minus 15 meter. Their repulsive nature becomes less prominent, and their attractive nature, because of strong nuclear force, becomes more prominent. So these two protons remains together inside the nucleus, and this is the strongest known force in compared to all other fundamental force. We will discuss this in nuclear physics, or when we will discuss radioactivity. This is just the introductory class of all the fundamental forces. And the fourth and last one is the weakest nuclear force. Again, as the name suggests, this is also a nuclear force, but it is only observed when there is beta emission. We know that radioactive substance like uranium, plutonium keeps on radiating to become stable. So radiation makes them stable. By radiation, these radioactive elements loses their energy and try to reach to its stable state. So the radiation can be of three types. All radioactive substance or radioactive elements emits radiation in form of alpha, beta or gamma. So when there is beta emission happens, we observe this weak nuclear force. See, this beta is nothing but the electron, but it is not the outer electron of an atom. This comes from the nucleus. A proton, a neutron breaks into proton and electron, plus some neutrinos are there, but this is again in higher class. So for this introductory class, we understand that weak nuclear force is observed when there is beta emission from the nucleus of an atom. So today we learn all the four fundamental force of nature, and these are gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Of all these four forces, The two, a strong nuclear force and weak nuclear force, belongs to nucleus of an atom, and the gravitational force and electromagnetic force can be extended to much larger scale. The gravitational force can be applied to celestial object and the electromagnetic force can also be applied. So these are more general, that is perceptible to human brain. But these two, the strong nuclear force and weak nuclear force, we need to understand deeper, and we need to learn a bit of nuclear physics to get to know about these two forces. So I hope you understand this class and you learn that there are only 4 fundamental forces in nature that exist, and all other forces, let it be centripetal force, centrifugal force, normal force, Coriolis force, any type of force, these are just derivation that we have derived, and we have come to the conclusion that let's consider these things a force. But in nature only these 4 fundamental forces exist. So I hope you understand. Thank you very much.